Hello all and welcome to this video on 3K where we're going to look at the families of quadratic and polynomial functions. This is the first time I'm using this document recorder, so we'll see how it goes and how the audio is and the video quality is, but I'm thinking it's going to work pretty well for now and I can do some of these at school. So let's get into the exercise. Families of quadratic polynomial functions. This is really important because it leads into the next chapter that we're going to be doing, which is called Gallery of Graphs, chapter 4, where we really expand on this idea of a family of a graph. Now, what does family of a graph mean? Well, this picture here sort of demonstrates it in that all of these are a quadratic. They are part of the family of quadratics. They are a type of quadratic, and they are adjusted in some way, shape or form. Some of them are moved up or moved down, they're moved left or right. As we go into chapter 4, we'll learn that that's called a translation. Some of them are flipped, they're in the standard form where they're a U shape, so standard. Some of them are flipped upside down, or what's called reflected. But all of these are a quadratic at heart and have just been adjusted in some way, shape or form. So they're part of the family of quadratics. And up here, okay, and you've probably seen this before in year 10, we have the equation for a quadratic. So we have actually the first one here, which is in the general form, and then we have what's called standard form or turning point. Okay, so if we can write a quadratic in any way in either of these two forms, and it will still appear the same, just changing how it's represented. As it says here, A, B, C, H and K are called parameters. Okay, now the only thing that's in common between these two is the A. Whatever the A in the general form is the same as the A in the what's called standard form or turning point form, that's the same. When we convert it though, H and K different to B and C, as they it's written in a different form. As we alter either A, B and C up here or A, H and K here, we get these changes that are occurring here, and we're going to spend most of the time looking at turning point, but we're going to use the general form as well. Okay, so let's have a look at using it, or a type of question that we might have. Okay, and it's generally this exercise and using families is picking which representation, which algebraic representation here is best to use. Okay, sometimes it might be best to try and solve a problem using the general form, sometimes it's using the standard form, or sometimes it's even good to use the intercept form where it's already factorized. Okay, so let's have a look at a question where we're already told a form. A family of parabolas have the rules of the form y equals ax squared plus c. So this is a reduced family. It's not the full one where we have a bx term. It's a reduced one where it's just ax squared plus c. It's still a parabola though, because it's a polynomial of power 2. For the parabola in this family that passes through the points 1, -1 and 2, 5, find the values of a and c. Okay, so first off the bat, if you're thinking back to linear equations or simultaneous equations, whenever we're trying to solve for an equation, we need the amount of points or information as there are unknowns. So at the moment I have one point known, I have a second point known, and I have two unknowns. So this means we should be able to solve this. Okay, I have two data points that I can use versus two unknowns, so I should be able to solve this. Okay, so what we're going to do is substitute in these points. So let's sub in 1, -1. So we get, let's have a look here. So we get -1 is equal to a 1 squared plus c. So we get -1 is equal to a plus c. Okay, now we're also going to sub in the second point into our original equation. So we get 5 equals a 2 squared plus c. So we get 5 equals 4a plus c. Okay, so what we have now, and I'll just grab a different color pen. What we have now, we could say that's equation 1 and that's equation 2. Okay. And from this we can do some operations, use simultaneous equations or substitution to solve these two for the unknowns. Noticing that we have a c in both of these, we could do 1 take away 2 or 2 take away 1, and that will cancel out the c. So I'm going to do 2, let's do 2 take away 1. Okay, so if I write this out just to show full working, I can go 5 equals 4a plus c, or, oh, no, I didn't want to do that there. We're going to take away -1 equals a plus c. Okay, and that's going to give us, so negative, so that's going to give us 6 equals 4a take away an a, that's going to give us 3a, c take away c gives us no c, so we get 6 equals 3a, so it follows on that a is equal to 6 on 3 is equal to 2. So we now have that. Okay, we now have that, so we can sub that back into one of these two here. So sub a into, we'll sub it into 1, so we get -1 equals 2 plus c. Okay, and now we can just solve this for c, so we get c is equal to -3. And from this we now know a, we now know c, we can write what this equation is. So we have y equals 2x squared minus 3. Okay, so this is a really simplified example of using a form of a quadratic and finding what the actual equation is from 2 points. So most of the questions are going to be similar to this. Okay. So let's go over the 3 main forms that you've seen or know. So the first one, okay, we like to call this intercept form, okay, or factorized, okay, or we can call it factorized form. This one here, okay, is called the standard form, okay, or you also know it as the turning point form, okay. And then this one here is the general form, okay, or very rarely, but it's just written as a polynomial. Okay, so they're the 3 forms. When are they useful? Well, it's what sort of information is. In intercept form, we know the e and f values, they are going to be intercepts, okay, when we solve it using the null factor form. The standard form, we know h and k is actually the coordinates of our turning point. Now, the general form, okay, isn't as straightforward in that we generally use that if we're just given 3 random coordinates. Okay, so let's have a go at using that. So using this idea that if we use the intercept form if we're given the x-intercepts and one other point, we use the turning point form if we're given the turning point coordinates and one other point, or we use just the general polynomial form if we're just given 3 random coordinates. Okay. So let's have a go at that. Example 2. A parabola has x-axis intercepts at -2 and 6 and passes through the point of 1, -30. Find the rule for this parabola. Okay, so straight away we're given intercepts, so we're going to use the intercept form. Okay, so let's write a parabola, equation of a parabola in intercept form. So y equals x minus e x minus f. Okay, we also know that our first x-intercept is equal to -2 and our second x-intercept is equal to 6. Okay, so we can substitute those in, so we get y equals a x minus, our first one is -2, x minus our second one of 6, so we know y is equal to a x plus 2 x minus 6. From here we can now, we only have one unknown, our a, we can use this point by substituting in. So we're going to substitute in 1 -30, so it follows on that -30 is equal to a bracket 1 plus 2 1 minus 6 15. Okay, and so we get negative 30 on negative 15 equals a, so a is equal to 2. Okay. Now it says find the rule for the parabola. Just writing out that a is equal to this and that we had e is equal to negative 2 and f is equal to negative 6, that isn't, we need to find the rule, so we need to write the rule. So we write y equals to x plus 2 x minus 6 to fully answer the question. So let's have a look at another example. Okay. The coordinates of the turning point of a parabola are negative 2, 4, and the parabola passes through the point 3, negative 46. Find the rule for the parabola. Okay, so straight away should jump out. We're given the turning point coordinate and we're given some other point. Okay, that's what we have been told. So if we've been given the turning point, we should use the standard form, or turning point, but if we want to use correct terminology, it's called the standard form. Okay? So we know for a standard form it's y equals a, make sure I get this right, x minus h squared plus k. Okay, and that is where x is equal to h is equal to tpx and k is equal to tpy. So it follows on from the TP being negative 2, 4. It follows on that h is equal to negative 2 and k is equal to 4. Now we have to be really careful when we substitute it in that this negative sign is different to this negative sign here. Okay, the general form already has a negative in it, so this whole thing has to go. That whole thing has to go in as the h, because that's technically what h is. So we get y equals a x minus, and then all of h squared plus, okay, we know k is 4. So from that we get y equals a x plus 2 squared plus 4. Okay, now to find the a, same thing, we're going to substitute in. Okay, sub in 3, negative 46. So it follows on that negative 46 is equal to a 3 plus 2 squared plus 4. Negative 50 is equal to a 5 squared. So we get negative 50 on 25 equals a. So a is equal to negative 2. Therefore, we can now write our whole equation as y equals negative 2x plus 2 all squared plus 4. Okay. So hopefully you're getting this idea is that the questions really roadmap or signpost what you should be using. Okay, if it gives you a turning point coordinate, straight away you should be using the standard form. If it gives you 2 intercepts, use the intercept form. If you're just given 3 random points, okay, you should be using the general form. And look at this. Okay, so parabola passes through the point 1, negative 2, 0, negative 3, 1, negative 1, comma, negative 6. Find the rule for parabola. If we're just given 3 points, okay, now it is good to note that one of this, that is an intercept, that's y-axis intercept, okay, but that's not very useful for our x-intercept form, okay, or our factorized form. So we're effectively given 3 random points, so we're going to use y equals ax squared plus bx plus c, and we're going to substitute these 3 different points in to get 3 different equations, try and do some operations with them so that we can solve for the 3 unknowns a, b and c. So let's have a go at this. So we're going to sub in. Straight off the bat, what we're going to do is we're going to sub in this because it's got a 0 in it, so we're going to get cancelled out a whole bunch of terms. So we get 0, negative 3. So it follows on y is equal to 0 squared plus 0x. I've got to put my negative 3 in. Negative 3 plus 0x plus c, so we get negative 3 is equal to c. So that's really nice and handy. So straight away we know that that is a negative 3 for the c. Okay, so now that we have that, we're going to sub in our next point. So we get 1, negative 2 we'll put in. So negative 2 is equal to a 1 squared plus b 1 equal to a plus b. We'll sub in our other point. A negative 1 squared plus, oh, I forgot the c, but we know the c, sorry, my bad. That's a minus 3, that's a minus 3 there. Okay, negative 6 plus b negative 1, and then our minus, instead of plus c, it's our minus 3 on the end. So we get negative 6 equals, that's going to be positive 1 because it's negative squared. So we get a minus b minus 3. So we can write that as negative 3 equals a minus b. And this one up here, quickly, I'm just going to write in underneath it. I know this is a bit messy, but add the 3, we get 1 equals a plus b. So we're going to call that equation 1, we're going to call that equation 2. And since we've got a positive b and a negative b, we will do 1 plus 2 to cancel out the b's, and that will allow us to solve for a. So let's have a go at that. So we're going to do 1 plus equals a plus b plus negative 3 equals a minus b. And that is going to give us negative 2 equals 2a. So a is equal to negative 1. So we can sub that, I'll write in red. We can substitute a equals negative 1 into 1. So we get 1 equals negative 1 plus b. So b is equal to 2. And now that we have a, b, and c, we can write our quadratic. So a was negative 1, so we get negative x squared plus 2x because b was 2, and then minus 3 for our c. And that's using 3 unknown points. So really, as you can see, this one takes a bit more work, okay? Especially, like, this was nice and easy in that it gave us one of the 3 points as the y-intercept, so we got c straight away. Sometimes that doesn't happen, it gives us 3 just generally random points. You end up with 3 equations, and then you have to use simultaneous equation operations to solve for the unknowns. Okay, so this one generally takes longer than the other two. The other two give you generally 2 bits of information straight away. Now, in that case though, and we can do this with our CAS. So let's have a look at doing this on our CAS. Okay, so right here, first off we need to define. So if I actions define, so that was menu 1.1, okay, and I'm going to type it in. Now I'm going to make sure that I include that at the start. Okay, this is a really good habit to be in because I can then use it when we call points, and later on when we do gallery graphs and we have multiple graphs that we're trying to plot on the one axis, we can call them up as f of x, g of x, h of x, whatever you want, but you should really be naming, okay, your functions like that. And the way we do it, okay, I'll move this up so you can see, okay, f of x equals there, and we just put it in general form, a 2 plus b of x. Okay, and I've made this mistake that I've made before, that if you have two letters together like that, it's not going to think of that as a times x. It's going to think of it as a variable that's combined, that's just called ax, like a word. Okay, it's just thinking of that as one variable. You need to make sure you put the multiplication sign in there between two variables, plus c. Okay, that's defined. Now we can use menu 17, I believe it is. So we go menu, no, it's 3 for algebra, and then 7 to solve a system of equations, solve, and we don't use 2 because that's only for linear. 2, so number of equations, we're going to have 3, and this is, go up, tab to go to the next one. This is really important. It's gone x, y, z, but that's not our unknowns that we're trying to solve for. We are trying to solve for our unknowns, which is a, b, c. So you have to type those in, which is a little frustrating, but you can do. Where's comma there? B, comma, c, enter. Okay, and so we get this. Okay, so you can put all your known points in. So if we go down to this example here, we are given coordinates of 1, 4, 0, 5, negative 1, 10. Okay, so you would put that in as f of 1 equals 4, f of 0 equals 5, and f of negative 1 equals 10, and we're going to solve for the unknowns ABC. Like I said, this ABC that we had to put in before has to match what you've defined as f of x before. Hit enter, and bam, it's done. It's given us A, B, and C. Okay. That is pretty much it. There's some questions for you to do using your CAS. Okay. Now these two questions down here, they aren't to do with CAS. Don't use CAS for these two, but it's more looking at them graphically and realizing it's not telling you in words what information is giving you, but recognizing in this case that's giving us the turning point, okay, and it's giving us intercept, okay, using that, which form of the equation is best to use to calculate what the, actually it hasn't given us the y-intercept, okay, but it's given us two other points and turning point. Which one are you going to use to try and solve that? Same thing here, it's giving us a turning point and another point, so of course you'd use the general, or sorry, the standard form of the equation to try and solve for that. And that is it for exercise 3K. If you have any questions, post them on our group site. Thank you very much.